In this session, we'll deal with how to make a factorial of a number and how to calculate the total number of permutations and combinations with respect to certain pair of numbers. So here the factorial of a number is been determined by the iterator, that is I is equal to 1 to num. Num is the deciding factor of the factorial number for which you need to calculate the factorial. So here the factor is initialized to 1 and factor into factor I is actually iterative value of the multiplicative factor of I to that particular number that leads to the factorial of the number. So initially I is equal to 1, then there is an iterative working making the I value 2. So 1 into 2 is a resulting fact. Then there is an iterative working making the I value 3. Then 3 into 2 becomes a resulting fact, that is 6. Then I iterator making the value 4. 6 into 4 is 24, is the resulting fact. Then there is an I iterator working making the I value 5. 24 into 5 is 120. So 120 is a number is a factorial of the number when the number reaches value 5. And at this point, when the number reaches 6 with iterator I increments the value to I num to 6, the for loop makes a final exit and the factorial is printed as 124 5. So this particular factorial definition is being utilized for the permutation and combination for these n and the n minus half definitions. So we know that as per the permutation definition, it is factorial of n divided by factorial of n minus half. So accordingly, that will be the return. And for combination, we know that it is the, according to the factorial definition, it's a factorial of n divided by factorial of r, the whole into multiplied by factorial of n minus r into n. And so that will be the whole dividing factor with factorial n. So that is a combination formula. So the whole of this, once the factorial definition, and once the permutation definition, and once the combination definition is utilized for with respect to certain value of the fact and NRI, that we are going to expose it in the static wordment, that is command and argument. So in num, we are declaring a specific number for which we need to calculate the factorial. So then with respect to the NNR, we are defining certain values. In case if n is 2 and we are r is 2, for 4 combinations, for example, we are taking 4 red balls. So 4 red balls will get, when taken 2 at a pair, we can make 12 such combinations. That is R1, R2, R2, R1, R1, R3, R3, R1, R1, R4, R4, R1, R3, R4, R4, R3, R2, R3, R3, R2, and R2, R3, and R2, R4, and R4, R2. So total 6 into 2 makes 12. So total permutations and combinations means we are avoiding the reverse pairing. That is, if R1, R2 is there, R2, R1 we are avoiding. And if that is been done for each of them, we can see that this total of 6 comes up. That is R1, R2, R1, R3, R1, R4, R3, R4, R2, R3, and R2, R4. So the total count of 6 comes up. 1, 2, 3, 4, 5, 6. So total counts with respect to the combinations, and total count of 12 comes for the total permutations with respect to 4 and 2. So then that will be analyzed by the h dot factorial method, and h dot permutation method will give the value 12 for n and for n being 4 and r being 2, and h dot combination gives the value 6 for the n being 4 and r being 2. So this is just the mathematical definition, and that is this mathematical definition will be depicted by these two methods. So we can go for the debugging session. We'll start with the bottom of the page, and where we need to get the output. So we'll go for share the page exactly its output is available. So we can give the factorial definition of 5. We know that it will be 120, and for n being 4 and r being 2, we know that permutations will be 12 counts and combinations will be 6. So accordingly, we can see that permutation is 12 and the combination is 6. So 12 permutations means the 12 pairings available, and combinations counts avoiding the reverse pairs, giving just the forward pairs. That is total count of 6. So thus we can define how the permutation and combinations can be done by making the utility of the factorial definition.